fairly common problem. Fundamental Theorem of Calculus here. I didn't give you an initial condition. I could have done that. All right, but right now I just wanted to talk about the maxes, the mins, and some values of the function as we go. G of x is defining the area under the curve of the piecewise function, which I drew up on the board. It's all lines. And it starts at 0. So the first thing I want you to catch is the first thing is g of negative 3. Well, that's the integral from what? 0 to negative 3 of f of t. But remember, we don't integrate backwards. So the first thing I want you to do when you see this problem, and you could write it again if you like, but we're going to flip the limits of integration, which means the sign of this thing is going to go negative. And I'm asking for the area under the curve from negative 3 to 0. Which is that triangle, right? Which is 2 by 3, 1/2 base times height, 1/2 of 6, it is 3. The answer to the first one is negative 3. All right. The second one asks for something completely different, right? The rate of change of g. Now, the instantaneous rate of change, g prime of 5. All right, so the derivative at 5. Now, the hard part here is recognizing when you have the fundamental theorem of calculus here, that if you take the derivative of g of x, you get what? Well, the derivative of an integral is simply the function. So g prime x is f of x. So if you want g prime of 5, that's equivalent to f of 5, which when I look on the board, I even have the ordered pair label. Oh, incorrectly. It is, if you roll 1, that's because I rolled 1. It's negative 1. That's all there is to it. G prime prime of 1. All right. If G prime of x is f of x, then G prime prime of G prime prime is equal to f prime of 1, which means on the graph above we are simply looking at the slope of that line. All right? And everybody, it goes from 0, 2 to 2, 0. You guys agree? Down 2 over 2. How about the slope of this is also negative 1. Right? So everybody, those three values. And the hardest part here is understanding this to this. We have to be able to use that. And again, this is the hard part in calculus. When do you look at the curve? When do you read the curve, right? Understanding those differences. Last one on this one. Where is g of x a maximum? Justify your solution. Everybody, if g prime, if I want to know where there's a local max, if g prime of x is equal to f of x, we know that when g prime of x goes from positive to negative, we have a local max opportunity, all right? So I am looking, when does f of x go from positive to negative? G of x goes, or f of x goes positive to negative at x equals 2, all right? Now, if I want to justify, all right, if I want to make sure, and the reason that this would be why this would be a local max for sure, whether it's a global max or not, we're not sure, all right, we would use the first derivative rule, right? This is the first derivative rule, right? The derivative sign goes from positive to negative, but I would write that out. If we want to justify this for the whole function, what else do we have to do? We have to show that we check the endpoints. We would have to check g of negative 3 for a value. We would have to check g of 7 for a value, okay, and find that. Now, g of 7 is going to be the area under the curve from 0 to 7, right? And hopefully I did this right. This area was positive 4, 2 by 2 triangle, okay? This area is a base of 4 from 2 to 6, a height of 1, but underneath, that's a negative 2. All right, so I got a triangle. I have a triangle here of area 2. I have a triangle here of area negative 2, which is 0. And then I have a triangle here 1 by 1, which is 1/2. Okay? I also have to figure out, I checked that endpoint, we knew g of -3 was -3 from the previous problem, right? So all I have to do now is check g at 2. Well, we just said, what's the area from 0 to 2? 0 to 2, the area is 2. All right? 2 by 2 divided by 2. So I will tell you right now that not only is g of 2 a local max, it is the global max. Its justification is twofold. First derivative rule, and then we check the endpoints, extreme value theorem. Right? You always have to check endpoints.